Hey, hello there. In this video I'm going to show you how to build this fracture tool. I made an animation and I posted it on Reddit, and this one is based on a tutorial that Default Cube did, but I added a few features that I needed, because what I saw in his tutorial that he breaks up every piece randomly, and then sometimes you get that all the pieces, if I go here into wireframe mode, that some pieces become really small and some never divide and they stay really big. So then you get a very irregular breaking up or very irregular fracture, and I wanted to avoid that. So what I did is I calculated the biggest piece, and it constantly cuts the biggest piece, and I do that by the face area. And what also happened in his fracture tool was that it always cuts from the middle, from the whole object. And what I did now is that every part is cut from the middle, from the cut part. So it calculates the middle of the mesh island and then puts the cutting plane over there. And I'm going to show you, this is the animation. Here it cuts. I baked this, so it's really quick. And here you see also that the cutting plane is subdivided and it has a little bit of irregularity. So it looks more like it's really cracked. Here I have an example what I encountered with the previous tutorial from Default Cube. Here you can see that it's based on the random mesh island and not the mesh area. So it takes a random value and using the ID as iteration, and then you can see if I keep cutting, I can keep cutting it a lot of times, and it takes really long until it cuts this really big part, and all the cuts accumulate over here. So I can keep going, eventually it might cut it, but the chance that it gets cut gets smaller and smaller because it takes a random number from all these new pieces that are being created. Then I also have the area test over here. This is the mesh island calculator, which I show you also. And if I go in, here you see a cube. So if I don't use the delete, then you see I have all these cubes. And if I use the delete, then you see it takes the biggest one and it calculates that by the surfaces. And I can also, let's turn this one off. If I take this one and say edge, subdivide, and subdivide it a lot of times, it's still taking all the surfaces together, and then it takes the biggest one. And if I use the smallest area, it takes the smallest object. So it does that from the mesh island and then accumulating the face areas. So by these examples, you can understand what I wanted to update in the fracture tool. And if we go into the geometry nodes, here this is what I did. Everything is in here. This is the fracture tool now, and I'm taking a icosphere and I'm using a surface relief and a Voronoi texture, and this is how that looks. I'm using that also within the fracture node, and I'm using the input value. You can also use it with an image, but here I'm using it with an input value, and then I'm multiplying the normal, and then you can set the map range by the from minus, from max to minus to max, and then scale the pattern. Yeah, you can do the scaling over here. But that's just the ball. You don't really need that. I can also just, no, it's baked, so I'm leaving it like this. And then I'm also projecting some particles on it, but I took these particles off. You can see here the particles. If I go into the shaded mode in Eevee. I remove the particles because that makes it a little bit slower now. So if I go back to the wireframe mode and then go into the fracture, I'm using scene time and multiplying it by 2, so it goes twice as fast, taking the seconds as iterations. And then when I go into the node group, you see here that it is a repeat zone, of course, and I'm taking the geometry that comes in and I'm using here a bounding box, and here it goes into the repeat zone, and I'm separating them every time, so I'm only using one of the mesh islands. So maybe you can see here if I use a viewer node and then go into preview, then use this one. Here you see you have the hole, it's somewhere over here, so it's not cut yet. Here I'm using a grid. Here it's cut. Let's see the grid. So this is the grid plane, and here it's subdivided, and I'm using the mesh and then calculating the bounding box around the mesh. So this is the mesh, this is the bounding box, and then I'm taking the minus vector and the max vector and use the distance and then multiplying that to use it as the XY size. So it's always twice as big as the object. So you never have the plane not cutting fully through your object. And I think that's very handy if you make very big objects or it places it very far from the center. It always finds the center and scales it up so you cut the whole object. Then I'm using a surface relief, so it gets a quite irregularity, as you can see. Let's scale it up a little bit. And then I'm using a solidify, and this solidify is set to if I go here, the margin is 0, so there is 0 space in between the cutted objects, and that's because I'm extruding it beyond the object itself. And this one is just a plane, and now it's at 0. But if there is a little bit of space, then you see that it has a little bit of thickness. But I want to have the option to cut it with 0 thickness for something, for certain things that you want to do. Then I'm instancing it on the ball. Let's see here. So here it is like this. Yeah, let's do it twice so you can see it. Here it's projecting it to the middle of the object because I'm taking here the mean position of this mesh island. So first here I'm splitting the object that comes in, and if we go into here, I'm taking all the face areas of the mesh island and I'm accumulating them, taking the total, and then use the minus and the max to use the minus and the max. Now I'm using the max, so I'm using the biggest mesh island to cut, and then I'm using that every repetition to split the geometry and then calculate the middle of it and put a point there. And then I'm putting this grid extruded here, the solidify extruded, as a cutting object. And you can see that here. So if I go into the Boolean, here you see the first half and this is the second half. And if you give this one thickness, I can like take out the bake maybe, and then we can see what happens. Here I have also a scale elements. So now you see that the cutting is 0, and when I put this to 10, there's a little space in between. So I wanted to have this option to use it for different kind of things that I want to do. and here you see that there's a space, but when it is 0 like this, then here you can see that it switches. So I'm using greater than 0, then it switches to the other one. And now here you can see that it has a little bit of thickness. This is, or is it this one? No, this is the block and this is the thickness. And if I give it like 10, it has a bit of thickness. When I give it 50, you see that it becomes thicker, and then it uses this one to cut. So let's delete this one. Now you see the two halves. If I put this on 0 again, half 1 and half 2, and here I combine them, and then you have this cut over here. What I'm doing next is here you can switch between if you want to use the smooth angle, and then I'm setting the material. So if I go into here and turn on with M, I mute it, and now I'm unmuting with M, so you can see the inside of the mesh, which is bright orange here, and I'm using the geometry proximity from the initial object, which is the uncut ball, and then I'm using 0 to 1. It works like this as well. No, you needed the map range to give it the right material. So if it's close to the outside, so like the surface is exactly on the surface of the cut object, and when it's really close it gives it this material, and when it doesn't it gives it the inside material. So this is the inside marble and this is the marble, and that seemed to work quite well to split these two, because when I try to extract the outside from the inside, there's no Boolean information when you use the float. I'm using the float here, and you have an intersection line when you use the manifold, but I couldn't use that in the float, but the float worked the best, so that's why I'm doing it in this way, using the distance. And then for the other nodes, this isn't really necessary to do, but I'm using the uncut to distribute points, and then put these icospheres with a surface relief on these points, and then I'm setting the position back to the geometry proximity and use the position. So if I plug this in, it's always, if I don't set the position, like it's on the outside object, and here I'm scaling the elements. So here you can see that it's projected onto the object, and when I scale them, they are outside of it. And then when I set the position back to the cut object, then they jump back to the object. And it's a little bit jittery, but this was enough for me to do this animation. Maybe in a later stage I'm gonna figure out how to project them directly on the fractured object so they don't jump around. But for this, maybe I should use the bake here again, so it goes really fast. Then you see that also the someone on Reddit said the material jumps around, and that's because I'm using just a coordinate system that is generating these Voronoi dots on it, and that's why it jumps a little bit. But you can also solve that with generating UV maps for these objects. I didn't have time to do this now. My main goal was to create this fracture tool. I can go over it again here so you can rebuild it. I show you again the mesh island calculation using the biggest island and cutting from there. And then the surface relief, this is how you build this one. And then you have the solidify, which is really basic. It's just extruding your mesh and then flipping the initial face and then joining them and merging them together. And I'm using also a smooth by angle. So that is the whole setup. I hope this is very useful for you, and hope to see you in the next one. Okay, bye.